All right, more exponent stuff, exponent rules, properties of exponents, but more specifically, we're going to talk about rational exponents. In case you don't remember, rational means fractions, basically, anything that can be written as a fraction. And so we're going to look at those. We're going to get how they work. If we got fractions in the exponent. So we're going to start by doing some definitional work here. And that is that if we have b for base, to the m over n, that equals a radical. We're converting rational exponents to radical form. So things like square root, cube root, fifth root, fourth root, etc., right? It equals the nth root of b to the m. So the top number is the power. The bottom number is the radical. You can also do it. It's the exact same thing as if we do b to the m. Whoa, what the heck has happened to this b here? Let's see if we can fix that. B to the m. So you can do the power first and then the root second. Either one of those works. So that's the way a radical exponent works. Let's do a few examples so we can understand what is happening. Excuse me. All right, so let's do some examples. Numero uno. We're going to write this in radical form, and then we're going to simplify it. So 25 to the 1/2. Okay, so that first to the first power doesn't matter, right? Because something to the first is that thing, right? So this is the square root, right? The only root that we don't actually have to put the number here. And the square root of 25 is 5. Because 5 times 5 is 25. Wow, that's not so bad. Number 2. We're going to take this one and we're going to write it in rational form. So if we have the square root of 18, we want to write this with a radical exponent. So this would be 18 to the 1/2. That's no big deal. Let's do another one. So if we have, for example, 3, if we have 5x to the 1/2. Now, this is an important example here because what's going on here is only the x is to the 1/2. If there were parentheses, then both of them would be to the 1/2. But in this case, only the x is to the 1/2. So if we want to convert this to radical form, we would take and we would turn it into the square root of x. So this is 5 times the square root of x. There we go. Easy peasy lemon squeezy. Let's do another one. Okay. This time we're going to just look at simplifying radicals. Okay. Let's add us a new one in here. Let's talk about actually, we don't even care about that too much. Let's go to here. Example, this is 4, yes, maybe? Yes, 4. Example number 4. Let's do 125 to the 1/5. Okay, so we're going to find the 5th root of 125. Now, what does that mean? It's very possible that you've only, at this point in your math career, the only types of roots you've seen is a square root. And the square root is what times itself equals that number. Well, a 5th root is what times itself 5 times x equals 125. So what times itself 5 times is 125. Well, 5 times 5 times 5 times 5 times 5 is 125. So the fifth root of 125 is 5. Okay. Let's do another one. Let's do one that's a little bit crazier, but still actually pretty easy. Not too bad. Let's do 64 to the 2/3. All right, this time we've got something on the top. Now, I said earlier, back when we were defining things, that you can do the root first or the power first. In a lot of cases like this, it's easier to do the root first because then we get it down to a smaller number before we square it or cube it or whatever else. So we're going to turn this into the cube root of 64 squared. Okay. So the cube root of 64 is 4 because 4 times 4 times 4 is 64. And then 4 squared is 16. Because 4 times 4 is 16. Easy peasy. Let's do one more of those, and we're going to learn one more power, do an example or two of that, and then we're going to call it quits. For this video, at least, right? We're not quitting on anything else. No, unless it's smoking. Smoking kills. How about 36 to the 3/2? Same idea. This equals the square root of 36 cubed. Right? Squared is the root, or the 2 is the root. So the square root of 36 is 6. And then 6 cubed is 216, because 6 times 6 times 6 is 216. All right, we're going to learn one more property, the power property. Power property says that if we have like bases raised to a power, so if x to the a equals x to the b, then a's got to equal b, which makes sense. A lot of these properties and postulates and things like that are almost no-duh kind of things because, and that's why they're postulates instead of theorems. You'll learn more about that next year in geometry. Theorems have to be proven. Postulates don't. Neither do definitions. So let's use that property in an example. Oh, there it is. That's what I'm looking for right there. Okay, so this is the type of example we might see with this property. So number 7. Number 7 is 6 to the x equals 216. Now, that's not what I said. Those two are not the same, so we have to make them be the same, right? Now, we just learned from our last problem that 6 cubed is 216, so that's what we have to do. We have to make this be the same base. So this turns into 6 to the x equals 6 cubed. So now the bases are the same. So we set the x when it's the same. So x equals 3. All right. Let's do another one. This one's going to be a little bit wilder, but we got this. We can do it. It's not going to be a problem. Example number 8 is 25 to the x minus 1 equals 5. So we need these bases to be the same. So we need to turn this 25 into 5. Well, 5 squared, excuse me, is 25, right? So we end up with 5 squared to the x minus 1 equals 5. Now, we've got a power to a power, we learned in lesson 1 of this unit that if we have a power to a power, we multiply those. So this turns into 5 times 2 times x minus 1. And that equals 5. Now, we got like bases. We've got kind of a single exponent. It's crazy, but we can set those equal now. If we have nothing there, it's to the first, right? So we can set the exponents equal. So 2 times x minus 1 equals 1, right? So we can either distribute this 2 in there or we can divide off the 2. We haven't practiced much just dividing off the number in front, so let's do that. It's going to give us a fraction, but that's okay. We don't mind fractions. Fractions are just numbers. Okay, we're going to take this and plop it up here. So x minus 1 equals 1/2. Now, I should note that doing this, divide the 2 off, it wouldn't have worked if like in here was plus 5 or something. Because then we would have had to divide 2 on everything. So it would have been divide by 2 here, and then would divide by 5, so 5 halves, et cetera, et cetera, et cetera. Right? So don't make that mistake. This works if it's just 2 times parentheses, and that's all that's there. And that works as a good strategy. So now what's attached to x? 1. It's subtracted, so we add it to get rid of it. Plus 1 plus 1. That cancels, leaving us with just x. 1/2 plus 1 is 1 and 1/2. Blapo. No big dealio. That's it, folks. That's all she wrote. We'll see you in the next one if you're one of my students. I'll see you in class. If you're not one of my students, I'm sure you are a wonderful, well-adjusted, happy, and healthy human being. Glad you joined us. Check out emberlearninglabs.com for more of what we do and all of those things. Enjoy the rest of this Algebra 1 course for free here on YouTube. Thanks. Have a wonderful, stupendous, happy, healthy, amazing